It's showtime.
Imagine you're streaming your favorite show and suddenly the video freezes. Annoying, right? Or maybe you're sending an important email and can't afford it to be lost. This is where TCP and UDP come into play. TCP ensures the email arrives perfectly intact, while UDP makes sure that the streaming stays smooth and uninterrupted. In the next few minutes, we'll dive into how these two unsung heroes of the internet make everything you do online possible without you even noticing.
The clean slate protocol, sir?
In cybersecurity, understanding TCP and UDP is crucial for securing network communications, detecting threats, and configuring firewalls and intrusion detection systems effectively. Knowing how these protocols operate helps in identifying vulnerabilities like port scanning, DDoS attacks, and spoofing. In DevOps, familiarity with TCP and UDP is important for optimizing network performance, managing load balancers, and ensuring reliable application development. It enables DevOps engineers to troubleshoot connectivity issues, configure services correctly, and monitor network traffic to maintain system stability and security. Knowing about TCP and UDP is essential because they are the foundational protocols for data transmission over the internet. Whenever a computer wants to talk to another computer or communicate, the exchange of information between these two machines must be strong and dependable in order to ensure the data is received accurately. When you wish to read an email, download a file, or browse a web page, for instance, you would anticipate seeing the web page complete, unaltered, and unbroken. Alternatively, you would prefer to get the complete file rather than just a portion of it because you wouldn't benefit the data that is missing or arranged incorrectly. So this is where TCP comes in. TCP stands for Transmission Control Protocol, and this is one of the main protocols used in the TCP or IP network. And TCP is what is used to guarantee that all the data is received and in order, because without TCP, then some of the data could be missing or out of order. Because if you view a web page without TCP, your web page could be all messed up. The images could be missing or the text could be backwards and out of order. Or if you download a file, then you might not get the entire file, or you could get the file out of order, which would render the file useless. So again, this is where TCP comes in. Now TCP is a connection oriented protocol, which basically means that it must first acknowledge a session between the two computers that are communicating. So the two computers verify a connection before any communication takes place, and it does this by using a three-way handshake. So the first step is that a computer will send a message called a sync, SYN. Then the receiving computer will send back an acknowledgement message telling the sender that it has received the message. And then finally, the sender computer sends another acknowledgement message back to the receiver. And then once this has been taken place, data can be delivered. Another important thing to remember about TCP is that it guarantees the delivery of data. So if a data packet goes and it's not arrived at a particular system, then TCP will resend it. Now UDP is very similar to TCP. UDP is also for sending and receiving data, but the main difference is that UDP is connectionless, which means that it does not establish a session and it does not guarantee data delivery. So when a computer sends their data, it doesn't really care if the data is received at the other end. And that's why UDP is known as the fire and forget protocol, because it sends data and it doesn't really care what happens to it. Another point to remember is because of the less overhead that's involved of not guaranteeing data delivery.
From now on, you have my trust.
But without a response, how will we know whether the UDP packet has been reached to the destination or not? For that, we have something called ICMP Protocol. When a UDP packet fails to reach its destination, ICMP can send an error message back to the sender. This helps in identifying issues like unreachable hosts or ports. Another point to remember is because of the less overhead that's involved of not guaranteeing data delivery, UDP is faster than TCP. So that's it. If you learned something new, make sure to hit the like button as it would really mean a lot. Thank you for watching. Please subscribe and I'll see you in the next video. Bye.